So welcome back. This is the second lesson of graphing quadratics. So just a quick review of what we did the last lesson. We graphed quadratics using vertex form. So something like this, we graph f of x equals y is equal to 3 times x plus 4 quantity squared minus 2. And we also talked about graphing something in standard form, which is y equals f of x equals y, which equals, let's say, 2x squared minus 4x plus 7, right? Something like that as well, we can graph, right? In vertex form, the first one, just by looking at it, we can see, we can find the vertex, we can find our axis of symmetry, right? And then we're going to use transformations to graph that from our parent function. And the second one, the standard form, our start point would be negative b over 2a. That's my axis of symmetry. X equals negative b over 2a. And then plug that into my function to get my vertex. And then from there, we have our axis of symmetry. And then we get two pairs of points, my second point through my fifth point, and then we can graph that, correct? Those are the steps. Now, I want you to notice that both of these equations start off with f of x equals y, right? That means that my y value equals the whole function, right? If f of x equals y is on one side of the equation and on the other side is my function, then y is my whole function, right? Whatever y is, that's my whole function. So the title of this part of the lesson is zeros of the function, okay? So if we analyze that in English, zeros of the function, right? That means zeros of the function means I'm gonna set my y value or my f of x value, which equals y, equal to 0, right? Zeros of the function, y equals my function. So I'm gonna set y equal to 0, correct? So if you think about that graphically, y equals 0, where is y equal to 0 here? Where would it be? The x-axis, right? The x-axis, that's where y is equal to 0, right? Along this line here, this horizontal line, y is always going to be equal to 0, correct? Now, there's no way around it. It's always going to be equal to 0, right? So when I find the zeros of the function, graphically, what am I looking for? What am I finding? If there's 2 points along this line here, let's say here and here, right? The x-intercepts, okay? So the zeros of the function, class, is also called my x-intercepts. And in previous classes, we found the x-intercepts by setting y equal to 0. Yeah? So we're essentially just finding our x-intercepts when we're looking for our zeros of the function. We just call it something different. Okay? So if you think about it like that, then finding the zeros of the function are pretty simple, right? Now, in this case, right, our last way that we're gonna graph, right? Again, we talked about vertex form, we talked about standard form. Now we're gonna get into factored form. Factored form, it looks something like this. Y is equal to x plus 3 times x minus 5. Okay? Each of these factors, okay, each of these guys here are called factors. Okay? All right, they're called factors. And let's think about it. If I'm gonna set y equal to 0 to find my x-intercepts or the zeros of the function, yeah, I'm gonna label this 0 equals x plus 3 times x minus 5. All right, notice what I said. I said 0 equals x plus 3 times x minus 5, right? The operation in between x plus 3 and x minus 5 is multiplication, right? Because I said times, right? If you read it out loud, 0 equals x plus 3 times x minus 5, right? Yeah, so we're multiplying the two things, correct? We're multiplying x plus 3 and x minus 5 together. X plus 3 and x minus 5 are just numbers. Yeah, they just represent numbers. Okay? So my question to you is, if I have two numbers that are being multiplied together and they equal 0, the product equals 0, what do I know about the numbers? Let me rephrase. How do I know, or how do I get two numbers, the product of two numbers to be 0? What do you know for sure? Give me two numbers that multiplies to 0. Any two numbers. 5 and 0. What else? 3 and 0. What else? 1 and 0. What else? Anything times 0. Correct? Anything times 0 equals 0. Right? 0 times anything equals 0. Right? Yeah? So what I know for sure, if the product of x plus 3 times x minus 5 equals 0, I know that x plus 3 has to be 0 or x minus 5 has to be 0. Correct? Yeah? In order for the product to be 0, one of these two factors need to be 0. Everybody understand that idea? Okay. So when I solve it for x, I'm going to subtract 3. I'm going to add 5. Right? And in this case, x is equal to negative 3. And in this case, x is equal to 5. So when x is equal to negative 3 or x is equal to negative or positive 5, then I know that the product equals 0, right? Yeah. And I also found, class, my x-intercepts. When x is negative 3, y is 0. When x is 5, y is 0. Yeah. So I found my zeros like that. That's how you find your zeros. That makes sense? Yeah. And then we're going to use those 2 points now to graph. Okay. So these are the steps to graphing in standard or in factored form. Okay. Step number 1, it should be 1B. 1a is we're going to set y equal to 0. Okay? If we set y equal to 0, then we're going to set each factor to 0. That is getting my x-intercepts. Right? Doing that gets my x-intercepts. And then from there, we're going to plot the points. Okay? So I'm just going to put x-intercept, comma 0, x-intercept, comma 0. All right? And my next step, class, going back up to my graph here, okay? I know that these 2 points will be a part of my parabola, wherever I graph it, right? Yeah, these 2 points will be along the parabola, yeah? And notice that they're directly horizontal from each other, yeah? Why is that important? What can I find now? The AOS. I can find my axis of symmetry. Yeah. If I have 2 points that are along a horizontal line like that, right? My x-intercepts. I know right in the middle, that's going to be my axis of symmetry, right? Because we've been doing this, 3 steps from the axis of symmetry. So I go 3 steps the same direction, right? To figure out the points. I'm going to do that here, but kind of backwards, right? And the easiest way to do this, to find the middle without any math, is this. So this is my axis of symmetry. That makes sense? Yeah, it's right in the middle of these 2 intercepts, right? So that's my next step here. Okay, I plot the points in the middle of the zeros, right? We plot the zeros, we plot the x-intercepts. In the middle of the zeros, there is the vertical line of my, or that there is my axis of symmetry, right? So x equals the midpoint of the zeros. Okay. All right. And then once we get the middle, once we get our axis of symmetry, the steps are the same. Once we get the axis of symmetry, we try to figure out our vertex by plugging it in, right? And then we found the vertex. So we have 3 points so far, right? After step 4. Yeah, we found our 2 x-intercepts and our vertex, right? We need our 4th and our 5th point. So step 5 is plug in 1 point for x and graph. That point is going to be usually going to be my y-intercept. Okay, so we're going to find our y-intercept and then graph it. And then once we find our y-intercept and graph it, we're going to use our x or our axis of symmetry to find our 5th point. Okay, so those are the steps to graphing in factored form. Okay. So our first example is the example actually used in our previous example to find our zeros. So that's our first step. Yeah. Our first step is to set my y value equal to 0 to find the zeros of the function or our x-intercepts, right? So if I do that, I'm getting f of 0 equals 0 plus 3 times 0 minus 5. We're going to plug in. Oh, I'm sorry. I did it the wrong way. That's not it. Y is equal to 0. So this is 0 equals x plus 3 times x minus 5. And we did the math up above. So I'll just set this equal to -3. Once I set this, x plus 3 equals 0 or x minus 5 equals 0, then x is equal to -3 or x is equal to +5. So those points are 0, comma, or -3, comma 0 and 5, comma 0, right? Yeah. So we got that. Okay. So now I'm going to go ahead and plot those points at -3 and 5. -3 is right here. 5 is right here. Where is the midpoint between these two numbers, -3 and 5? 1. At 1 lies my axis of symmetry. All right? Okay? So I got that, right? At x equals 1. I'm going to take my axis of symmetry to figure out my vertex. Okay, so step 4 in your steps, I'm going to plug in the axis of symmetry. X equals 1. So I'm going to get f of 1 equals 1 plus 3 times 1 minus 5. Right? So now I have f of 1 equals 4 times -4, which is -16. Right? So my vertex I have at 1, comma, -16. Cool? Questions? Yeah.
So it's like you find like the negative in 0 and the 5 and 0 is 2 points, and then you just get the vertex right after.
Yep. Yeah, these are the steps to solving this. So 1, comma, -16. Since -16 is such a big number, I'm going to make each of them 4. Okay? So it's going to be like right here. Right? So now I have 3 points, right? I have my vertex. I have my 2 x-intercepts or my zeros. Now I got to plug in a random number, right? To figure out how it's going to be shaped, right? My 4th and my 5th point. I'm going to find my y-intercept. Okay? To find my y-intercept, I'm going to make x equal to 0. So if I make x equal to 0, f of 0 equals 0 plus 3 times 0 minus 5, right? So that's going to be f of 0 equals 0 plus 3 is 3 times 0 minus 5 is -5. So that's -15. So my y-intercept is 0, comma, -15. Right? When x is 0, my y value is negative 15. Yeah. Okay. Plotting that point on my graph, 0, comma, negative 15 is like right here. Yeah. So here, I'm 1 unit away. So go 1 unit away. That's my 5th point. And then I go ahead and I graph it out. Yeah. Okay. Okay. So that's the work for this. Our next example is this. We're going to determine the y-intercept. I'm going to also add the x-intercept along with graph. Okay, we're going to do all of those things. Okay. So to find my y-intercept, we make x equal to 0. Always and forever. Okay. So if x is 0, then f of x, which equals y, yeah, is equal to 0 plus 5 times 0 plus 1. Yeah, make x equal to 0. So f of 0 equals 5 times 1, which equals 5. So my y-intercept is 0, comma 5. Yeah, simple, easy. Just plug in x equals 0. To find my x-intercepts or my zeros of the function, okay, we're going to make y equal to 0. So if y is 0, then 0 equals x plus 5 times x plus 1. So x plus 5 equals 0 or x plus 1 equals 0. So I'm going to subtract 5 on both sides, subtract 1 on both sides to get x is equal to negative 5 or x is equal to negative 1. And so if we're left with negative 5 or negative 1, then I know that my x-intercepts are negative 5, comma 0 and negative 1, comma 0. Right? Honestly, class, the steps from above, right? You can do it in any order that you want. I got my y-intercept and my x-intercept first. Okay? The previous example, I got my x-intercepts and then I got my vertex and then my y-intercept, right? But in this example, I'm just getting my vertex last. Okay? So if I go ahead and graph these 3 points, I can figure out my vertex. Okay? I'm pretty sure I can figure out my vertex somehow. So there's my graph, right? I'm going to plot these points 0, comma 5, 1, 2, 3, 4. Oh, 5 is right there. My x-intercepts, negative 5, 2, 3, 4, 5, 0, and negative 1, 0. So where's my y or my axis of symmetry? Negative 3, right? Halfway between is the midpoint yeah, at x equals -3, right? So if x equals -3, I'm going to plug in -3 back into my function, okay, to figure out my vertex. So x equals -3. That means that f of -3 equals 0 plus 5 times, oh no, -3 plus 5 times -3 plus 1, right? -3, -3, -3, right? So f of -3 equals 2 times -2, which equals -4. So I have my vertex at -3, comma, -4, right? Okay. So plot that point, -3, comma, -4, 1, 2, 3, 4, right here. That's my vertex. So I have 4 points, right? Right now. I have 4 points. 2 x-intercepts, my vertex, and my y-intercept, right? So from my y-intercept, right here, since this is 1, 2, 3 units away, go 1, 2, 3 units away, and there's my other point. Does that make sense? Yeah. Now I got my 5th point, and then I can draw a smooth parabola. Okay. Any questions on this? No? That's the lesson for today, class. Thank you very much.